We're going to talk today about climate change. Scientific evidence that climate change is happening and that it's human-caused and that we have to act today to avoid dangerous impacts is overwhelming. Yet current policies and actions fall far short of what the science tells us we need to be doing to address climate change. This may be obvious to many of you, but it's not to everyone. And we'll talk about why that's been a challenge for us as a society to accept that science and act accordingly. Okay, so this chart depicts that gap between what the science tells us needs to happen and what current actions are. So it shows the human-caused greenhouse gas emissions, what those have been historically, and that they've continued to rise. We had a short decline in 2020 during the pandemic, but it rebounded pretty quickly. So it shows the historical emissions, and then it shows future emissions pathways and the resulting temperature rise that we're going to see under those different pathways. So the top bar, the peach bar, it represents warming that we would experience if we adhere to the current climate-related policies that various governments around the world have put in place. The blue band represents the warming that we would see if all countries adhered to their international climate pledges that they submitted to the United Nations under the Paris Accords, which we'll talk more about. But you can already see that there's a gap between the current policies that governments have in place and what they've pledged internationally. And then the green band at the bottom, it shows what scientists say we need to aim for in order to stabilize temperature rise and limit warming to 1.5 degrees Celsius to avoid the worst impacts of climate change, which is a really steep departure from emissions historically. So I want to give you guys a framework for thinking about how to solve complex science-based issues like climate change. So to solve issues like climate change, you need three components. You need the science, you need a clear understanding of the causes and impacts of the problem that you're trying to solve. You need solutions, so viable technical and policy solutions for solving the problem. And you need social will. You need support by the public and or politicians, depending on the structure of your government, to address the problem and implement solutions. So for climate change, like I already said, the science is settled, right? The evidence that climate change is happening, that it's human-caused, and that we have to act today is overwhelming. On solutions, maybe 10 years ago, solutions were too expensive to really scale and solve this problem. But since then, we've seen lots of innovation and cost declines in technologies like solar, wind energy, electric vehicles, and batteries, to the point where we have economically viable and scalable solutions to address this problem. Something that we'll talk about a little bit more later as well. There are certainly some areas where we can continue to innovate, like in the aerospace industry, but those are relatively small portions of our energy mix. So we have the science, we have the solutions, but where we're really missing in this three-part framework is with the social will. We as a society have struggled very much to garner the social will among the public and among our policymakers to not just acknowledge that climate change is happening and needs to be addressed, but also agreeing on action to solve it. So in the remainder of this presentation, I'm going to walk you through this framework. We're going to talk about the science of climate change, we're going to talk about the social will, and then we're going to talk about the solutions. So let's start with talking about the science. What are the causes and the impacts? So Earth's climate is supported by the process known as the greenhouse effect. Greenhouse gases occur naturally in our atmosphere, and they regulate our Earth's temperature. When sunlight enters the Earth's atmosphere, some of it gets reflected back out into space as light, while the rest gets absorbed by the Earth and then re-radiated as heat or infrared radiation, and greenhouse gases trap that infrared radiation. So as greenhouse gases rise in our atmosphere, so do temperatures. And we've known this for a really long time. You can see this quote from Svante Arrhenius at the top here. This chart shows what greenhouse gas concentrations are in the atmosphere, specifically what CO2 concentrations are, carbon dioxide, which is the most prevalent greenhouse gas, dating back hundreds of thousands of years. And we got that historical data from ice cores in Greenland and Antarctica. But more recently, we've also been doing direct CO2 measurements at places like the Mauna Loa Observatory by Charles David Keeling, or now his son. They began measuring that in 1958. So you can see that for the last 800,000 years, CO2 levels in our atmosphere have fluctuated largely between 180 parts per million and 280 parts per million. But you see this sharp and sudden increase at the end of the chart. That's where we are today at about 420 parts per million of CO2 in our atmosphere, which is a huge departure from hundreds of thousands of years prior. And it's due to the significant increase in carbon-intensive activities since the Industrial Revolution, in particular our energy usage. So greenhouse gases, like CO2, they're well-mixed gases. So that means that if you measure greenhouse gases at the Mauna Loa Observatory, it's representative of what greenhouse gases are in the rest of the world. This means that CO2 from the US or China impacts the rest of the world, unlike some of the local air pollutants, which are more localized. All right, so let's talk about the different types of greenhouse gases. I mentioned carbon dioxide is the most prevalent greenhouse gas and responsible for the most warming. You've also got methane, nitrous oxide, and fluorinated gases. So methane has several sources. It's the main component of natural gas, but it also comes from things like landfills and livestock. Nitrous oxide shouldn't be confused with nitrogen dioxide, which we'll talk about in maybe about a week and a half. But nitrous oxide comes from agricultural soil management, like fertilizers. And then you've got the fluorinated gases, like hydrofluorocarbons, that come from, they're man-made, and they come from things like refrigerants and have been used as a substitute for ozone-depleting substances. So each of these gases have different heat trapping potentials and lifespans. So in order to understand the overall levels in our atmosphere and their contribution to climate change, we normalize the different greenhouse gases using what's called global warming potentials, or GWPs. And so GWPs are a measure of how much heat trapping potential a greenhouse gas has over a given time span relative to carbon dioxide. So this is why we often see greenhouse gases measured in what's called CO2 equivalencies, or CO2e or EQ, like you see in this chart here. When you see that, that means that the greenhouse gases have been normalized based on their heat trapping potential and lifespans. So the table on the right here, it shows the different global warming potentials, internationally recognized standards. So methane, it has a lifespan of about 12 years, and it has much higher heat trapping potential than CO2. So the global warming potential for methane over 20 years is just over 80 times. And then the global warming potential over 100 years, because methane has a shorter lifespan than CO2, which can stay in our atmosphere for 100 years or more. Methane has 27 times the heat trapping potential of CO2. A lot of data that I'm gonna show you, like this pie chart right here, it comes from the US Greenhouse Gas Inventory, which is released annually by the Environmental Protection Agency. And the numbers that the US Greenhouse Gas Inventory uses are sometimes contested and criticized for not incorporating up-to-date global warming potentials, and also using global warming potentials that maybe they shouldn't. For example, the EPA Greenhouse Gas Inventory uses 100-year global warming potentials when really what we care about is the warming that we're seeing today and the warming that we're going to experience over the next 20 years or less. So because they're using 100-year global warming potentials, EPA, some people might say that EPA is understating the impact of methane. I want to call out black carbon that's listed here. It's not a greenhouse gas. It's associated with particulate matter, another one of those localized air pollutants that we'll talk about in a week and a half. But even though it's not a greenhouse gas, it does have significant heat trapping potential. It's more localized. It stays in the atmosphere for a lot less time, but it has, if we can reduce that, it could have an immediate impact on the heat trapping gases that are in our atmosphere. Okay, so those are the types of greenhouse gases. Let's talk about where greenhouse gas emissions come from in our atmosphere, at least anthropogenic. Anthropogenic means human caused. So this chart shows the sources of emissions as reported by various countries to the United Nations. And you can see that the sources of greenhouse gases are pretty varied, ranging from electricity generation to transportation to agriculture. But you can really slice and dice this in different ways. If you look at sources that are related to our energy use, energy is the #1 contributor to greenhouse gases around the world, making up about 76% of our emissions. And this is because the energy resources that we have at least historically used to power our lights and move our cars around have predominantly been very carbon intensive. And this is one of the reasons why climate change is something that we talk about a lot in this course. And we talk about it in the second class. It's a really important topic when it comes to our energy resource use. So the result of the recent increase in CO2 emissions and global greenhouse gas emissions that we've seen in our atmosphere is that the Earth is experiencing a changing climate at an unprecedented rate, with significant impacts already being felt by humans today. When I first started teaching this class, I really had to emphasize this point that we're seeing the impacts today, because a lot of people think that climate change, it's not something that's going to impact them. They can procrastinate. They don't need to think about it today. But a lot is happening. So let's talk about what those impacts are. I also want to highlight that a lot of the data that I'm going to show you comes from an entity called the Intergovernmental Panel on Climate Change, which is the IPCC. It's an international group established by the United Nations that includes 1,300 international scientific experts. I mean, it's really considered the ultimate authority on climate change and climate science. So according to the IPCC, since pre-industrial times, global average surface temperatures have increased almost 2 degrees Fahrenheit, or 1.1 degrees Celsius. May not seem like a lot, but in the context of the Earth system, that can have significant impacts that we'll talk about. So when we talk about climate science and impacts, we often look at charts like these that doesn't always resonate with folks, right? It's just a line on a page. But scientists and others have gotten more creative about trying to convey the impacts in a way that hits home for folks. Like this beautiful rainbow chart. My toddler would love it. So what we're seeing is more frequent hot weather and heat waves that's driving up air conditioning demand for folks that have air conditioning and creating unbearable and unhealthy environments for folks that don't. The 2/3 of the population that doesn't have air conditioning. It means severe and unprecedented drought, particularly in the western US, which reduces water supplies and strains hydropower resources, as many communities are feeling who rely on the Colorado River for their water resource. I mentioned that I lead the Nevada Clean Energy Fund, Nevada's Green Bank. So I like to use this example from the southern Nevada area, the Las Vegas area. These images and charts show Lake Mead above Hoover Dam, which is on the border of Nevada and Arizona, right outside of Las Vegas. And Lake Mead is one of the many lakes that's fed by the Colorado River. And you can see that water supplies have been dwindling significantly over the past several years. Southern Nevada, they already recycle all of the water that goes down a drain, which is pretty impressive. They recently banned evaporative cooling. So all commercial buildings and residential buildings are going to have to get rid of evaporative cooling in the coming years. But it gives you a sense of the extreme measures that some of these areas are having to take in order to adapt to this increasing drought and dwindling water resources. And the situation with the Colorado River is getting so bad that the federal government recently intervened to reallocate the water resources and reduce them. Also, because of climate change, we're experiencing more common weather conditions that are conducive to wildfires, which have been increasingly devastating the western US in recent years. I know the Stanford campus experienced it. This is a chart that actually came out of Stanford University's Environmental Change and Human Outcomes Lab that shows how exposure to air pollution from wildfires has significantly exacerbated just over the past few years with impacts on human health, particularly for young children whose lungs and brains are still growing. Okay, so as a result of temperature increases, we've seen Arctic and Antarctic sea ice melt at unprecedented rates. We've also seen sea level rise by nearly a foot due to a combination of thermal expansion and the loss of land-based ice. In March of last year, Antarctica experienced a record heat wave with temperatures jumping by nearly 40 degrees Celsius or 70 degrees Fahrenheit above normal. And this heat is likely what triggered the collapse of the Conger ice shelf, which you can see satellite imagery of here, which was really surprising to scientists because historically the East Antarctic ice shelf has been considered, fairly stable. While it may be hard to connect what's happening in Antarctica to ourselves, huge loss of land-based ice happening there results in sea level rise. And it means flooding in low-lying areas, like in Florida, or even in the Bay Area. The Bay Area has lots of low-lying areas, IKEA, East Palo Alto, but also other nations like the island nation of the Maldives, which you can see a satellite image of here, that are particularly vulnerable to the impacts of climate change and sea level rise. I think we heard about Jakarta as well. All right, so we've seen increasing ocean temperatures because of climate change and as well as ocean acidification. Our oceans are what are known as carbon sinks. So similar to our biomass, like our trees, our oceans absorb carbon dioxide. That's why they're called carbon sinks. So as atmospheric CO2 levels rise, so do oceanic CO2 levels, causing ocean acidification, which is harmful to coral and other calcifying species like oysters and clams. The world's coral reefs are also experiencing accelerated bleaching events due to rising ocean temperatures. Coral bleaching is a sign that coral is under stress and could lead to the death of that coral. So in March 2022, the Great Barrier Reef in Australia experienced a mass bleaching event after having several unprecedented mass bleaching events over a short period of time. All right, and we've also been seeing increases in the severity of extreme weather events, ranging from droughts to heat waves to hurricanes. It's all very depressing, but don't worry, we're gonna get to solutions very soon. So climate change, all of these impacts can lead to the displacement of tens of millions of people and have led to the displacement of tens of millions of people each year because they're unable to adapt to the increases in temperatures or flooding, droughts, hurricanes, and these other climate-related impacts. All right, and one last note on impacts. We also have what's called positive feedback loops, whereby increases in temperature trigger additional increases in temperature or greenhouse gas emissions. I'll give two examples. The permafrost in the Arctic Circle over here is a layer of frozen rock and ice that naturally contains a lot of methane. So as the permafrost thaws due to rising temperatures, the CO2 and CH4 that's trapped in that permafrost gets released. The permafrost picture is here of somebody lighting the CH4 coming out of the permafrost on fire. Another positive feedback loop is a reduction in the Earth's ice albedo. I mentioned earlier that a portion of sunlight that enters the Earth's atmosphere gets reflected back, and rather than absorbed by the Earth and then re-emitted as infrared radiation. So the Earth has an albedo of 30% because about 30% of that sunlight is reflected back from primarily ice, but also white surfaces and other reflective surfaces. So as the ice melts, Earth's albedo decreases, reducing the Earth's ability to reflect that sunlight and causing that positive feedback loop. Another less biological one is the fact that rising temperatures are driving increased air conditioning demand. And if that air conditioning is being powered with fossil fuels, that's going to result in more greenhouse gas emissions. So feedback loops, they're complex and hard to predict, but scientists do try to measure them, model them into their future models of what types of temperature rise we're going to see in the future under different emission scenarios. Okay, so we talked about the science. Let's talk about how we garner the social will to act on climate change. So scientists, the scientific consensus that climate change is happening and it's human-caused is overwhelming. You don't generally see this type of scientific consensus on issues, ever. But the American public differs in opinion quite starkly from what the scientists say. What do you guys think some of the reasons are that there's this disconnect? Yeah, I think that's a great point. Generally, scientists historically haven't really done a good job of advocating for their work and their findings. It was actually frowned upon for scientists to do so, but because climate change has been so misrepresented by the media, we've seen scientists more recently take much more of a proactive role in advocating around their climate research and saying, hey, like, we need to solve this. Like Stephen Schneider was one of the first scientists to do that, which you guys had a video about him. But he was criticized, at the time that he was doing interviews like you saw.
Are there prominent climate scientists out there that don't believe climate change is happening?
I think that there are some scientists out there who aren't necessarily climate scientists, who are funded by fossil interests, who to say different things. And find different things, but yeah. Which is another reason why we have this disconnect and the misrepresentation in the media, right, is we've seen incumbent fossil fuel interests engage in deliberate misinformation campaigns. Chief among them was ExxonMobil, but we are seeing increasing litigation about those misinformation campaigns. Those fossil fuel companies being held accountable for basically lying and withholding information about the products that they sell. Another big reason why it's so hard for folks to grasp the climate science and internalize it is because it's scary. I think the climate community has realized over time that it's actually not a great way to motivate people to just talk about how the Earth is on fire and we're all gonna be living in the dark ages if we don't act, right? It scares people, they shut down. So, and they feel helpless, right? Because it's such a big, massive issue where even if they change their own lifestyles, it's not gonna solve the problem, right? So the climate change community has realized that it's really important to talk about solutions and empower people to act as a way for them to engage on this issue. So bear with me, we're gonna get to the solutions in a little bit. This is a very partisan issue, one of the most partisan issues in the US if you're looking at the difference between Republicans and Democrats. So people aren't necessarily looking at this issue based on the science, they're looking at this issue based on their personal and their political values. All right, so let's have another discussion. Let's talk about what some of the effective ways to communicate about climate change are. For me, one of the ones that resonated was the David Roberts article, The Best Way to Reduce Your Personal Carbon Emissions, Don't Be Rich. It's the misleading title, but I think gets to this point of, this is a systemic issue. It's not an individual, personal issue where we all, any one person should feel responsible and act. We need to change the rules of the system and engender systemic change. So this is one of the, I think, the big challenges of this issue and motivating people to act. I hear from a lot of students that the James Baylog Chasing Ice video is very impactful, and I think it's hopefully one of your takeaways that you're getting from this is, different messages resonate with different people, and folks who are already environmentally inclined or already bought in to the fact that climate change is happening, they might be motivated by the Baylog video because they know it's part of a trend, right? Rather than just like a weather-specific happening. Or they might get motivated by the charismatic megafauna, right? The picture of a panda bear or of a polar bear. But there are others who won't, significant portions of the population. So it's really important that we think strategically about how we communicate about climate change to different populations. And so there's a whole field of behavioral psychology focused on this. It studies how and why people react to climate change in the way that they do, and what are the communication techniques that are the most effective. So the Yale Project on Climate Change Communication does a lot of great work in this area. They study US public opinion about climate change, and they've identified 6 segments of the population based on how they think about climate change. Starting over on the right-hand side, you've got people who are dismissive, small portion, 9% of climate change. They don't believe that it's happening. You've got others that doubt that it's human-caused. You've got a really small portion, 5%, that just don't engage or think about it at all. You've got a larger segment, almost 20%, that are cautious. They haven't made up their mind yet. But the biggest segment is, I'll jump over to the alarmed segment. They're convinced that global warming is happening, that it's human-caused, and that it's an urgent threat, and they support policies and solutions to address it and act. And then the second biggest segment are the concerned. About a fourth of the population think human-caused global warming is happening, and they're concerned about it, and they support climate policies, but they just have other priorities, right? They don't think that it's something that they really need to think about today because it's not, the impacts of climate change are still distant either in time or in space. So climate change is a lower priority issue. So you can imagine that targeting communications to the alarmed and concerned segments can be very effective in moving the population, a big portion of the population, to act on climate change. The alarmed, they just need to be empowered with solutions, right? Concrete actions that they can take and that they can help society take to address this issue. And the concerned, they need to get communications about making climate change real for them, right? So if a hurricane happens, tying that to climate change and showing them how it impacts them so that they can internalize that immediate risk that we're seeing. With these maps, you can see that we've got a big segment of the population. One of the reasons why we have a big segment of the population that's concerned, right? You've got a significant portion of the population, about almost 2/3 of the population believes that global warming is going to harm people in the US. But on the right here, a much lower percentage believe that's going to impact them personally. Another striking thing for me is that 64% of Americans say they rarely or never discuss climate change. It's something that I take for granted, working in the clean energy and climate space, being here on campus. I talk about climate change all the time with my family, my colleagues, my friends. But it's a conversation that's not happening in the vast majority of the US. So it's one of the reasons why I get really excited about education and awareness efforts, particularly focused on these purple areas. All right, so we talked about some of the human biases and kind of behavioral challenges that make it hard for the public to accept and act on climate change. A second reason why social will is hard to garner that we talked about earlier is because of the equity issues and these political issues surrounding climate change. The carbon budget, it's limited, right? It's depicted by this bucket here, where we've almost nearly depleted our carbon budget, beyond which we start to get into more dangerous impacts of climate change. Because scientists have said we need to limit warming to 1.5 degrees C if we want to avoid those worst and harmful impacts. So we have a limited budget, and without regulation or cooperation, we're on track to completely deplete our carbon budget. And the stakeholders involved include over 200 countries with varying levels of contribution to the problem and different levels of ability to adapt to the problem. So a lot of discussion in the international climate negotiations between countries that have been trying to agree to collective action on climate change focus on who has the most responsibility to act. If you look at it on an annual emissions standpoint, you might conclude that clearly China is the one that needs to act because they're the biggest emitter. But there are other ways that we can look at CO2 emissions and think about who has the responsibility. Can you guys think of others besides annual CO2 emissions? Cumulative, yeah, historical, because like we talked about, CO2 remains in our atmosphere for 100 years or more. Yeah, so normalizing it based on income and wealth. You guys touch on a lot of these. You've got CO2 per unit of GDP, that's known as carbon intensity. GDP stands for gross domestic product and is a measure of a country's economy or income. HDI is similar, the Human Development Index. It takes into account a country's economy, but also other social factors that contribute to things like human development. All right, TPES is total primary energy supply, so it gets at this point of measuring it based on your consumption of carbon-intensive goods. All right, so if you look at it on a per capita basis, China drops down, looks a lot better than the US and Canada and Australia. So this shows CO2 emissions per capita by the top greenhouse gas producing countries. It doesn't show the top GDP or CO2 per capita countries because most of those are just oil producing states. And if you look at it on a cumulative basis or historical, the EU and the US are the biggest emitters, and so many would say the biggest contributors to the climate change that we're seeing today. Looking forward though, developing countries, and in particular China and India, are going to account for the bulk of increases in greenhouse gas emissions. Like we talked about earlier, emissions from the developed world have largely stabilized, and we're seeing most of the growth in the developing world, who's continuing to pursue economic development. It still has a lot of population growth, et cetera. But part of the challenge is that these countries, like we discussed, they still have economic development challenges, right? They want to grow their economies to be on par with the developed world. Many of them still don't have access to electricity. About a third of the world still lacks access to electricity. And so, the US and the EU, they don't have any right to tell the developing world to rein in their emissions and potentially hamstring their economic development when the developed world carries most of the blame for the climate change that we're seeing today. To make things even more complicated, the hardest hit by climate change are the poorest populations of the world that have contributed the least to climate change in the first place. So a lot of the conversations in the international climate negotiations are also about what responsibility the developed world has to help these most vulnerable countries adapt to climate change. So these big questions related to equity and climate change have made ambitious progress in the international climate negotiations pretty challenging, and we'll talk more about that in a minute. Let's talk about solutions, finally. All right, so closing that emissions gap and solving climate change, it's a pretty significant undertaking. There's no one silver bullet. We're going to need multiple different large-scale actions across the world in order to close this gap. It calls for not just a continuation of some of the climate solutions that we're seeing scale right now, but a huge acceleration of investments in those low carbon solutions. But it is achievable, and we've seen studies and examples in real life that show that it is technically and economically feasible because we have the solutions already at our fingertips. We just need to deploy them. Before talking about those specific solutions, though, I want to revisit the source of the problem to understand where to target our solutions. Because measuring and understanding the source of the problem is a really critical first step in solving it. This, in a slightly different way than what you saw before, it shows the sources of emissions, global anthropogenic emissions, on the left-hand side, and on the right-hand side, it shows the carbon sinks, the ocean and biomass land sinks. So, I think this is a useful way to look at sources, but you can slice and dice it in different ways. You can break electricity out into its various end-use sectors. You could break it down by country and then by sector. You can even break it down by the different types of energy uses, like heat or motor drives. Motor drives make up a big portion of our energy use and electricity use. It's also really important to keep in mind that the data that you're looking at is only as good as its source. The information that we have on greenhouse gases is not 100% perfect or comprehensive. This is one of the reasons why we have a lot of efforts, including here at Stanford, to better measure sources like methane from the oil and gas supply chain. So top-down macro data like this should always be complemented by bottom-up measurements so that we know where emissions are coming from and are able to fix them. So one of the ways that stakeholders measure greenhouse gas emissions in a standardized manner is through what's called Scope 1, 2, and 3 emissions. So stakeholders have created these standardized methods for companies and organizations to follow, including universities like Stanford, for accounting for their greenhouse gas emissions. So the scopes split emissions based on the control that an entity has over their emissions. So Scope 1 includes direct emissions from an organization, like for company-owned vehicles, for example. Scope 2 includes indirect emissions, so emissions from electricity or heat, say that's bought from a utility. And Scope 3 includes all other indirect emissions, like the emissions if you buy a manufactured good, the emissions from the creation of that manufactured good, like a laptop, for example. And one of the big developments that's happened in the US in the past year is in March of last year, the Securities and Exchange Commission, the SEC, proposed a rule that would require public companies to disclose their Scope 1, 2, and 3 emissions. So to investors, which is a really big deal. Public companies haven't had to do that. It creates liabilities for them, right? Because they have to be accountable to the SEC and the numbers that they release. So if they fudge their numbers or if it's not right, they could get sued, for example. So prior to this ruling, all greenhouse gas reporting that's been done by companies has been voluntary and not subject to any significant oversight or accountability. The SEC should be coming out actually in the next month or so with more guidance around what that kind of climate risk accounting for public companies looks like. So something to look out for if it's something that interests you. All right, so measuring is important and a first step before deploying solutions. All right, so let's talk about solutions frameworks. There are lots of great science-based frameworks that map out the different cost-effective pathways for stabilizing our greenhouse gas emissions to safe levels. Project Drawdown is one of them, and this pie chart captures some of the data from Project Drawdown. You can see from the solutions that they mapped out, energy is a big component of the solution. But in addition to that, you've got a big component that's natural and engineered sinks, the so-called negative emission solutions that take carbon out of the atmosphere. 10 years ago, carbon sinks were not a part of the discussion in the climate change sector when we talk about solutions, in part because scientists didn't want first of all, it can be fairly expensive and challenging to scale carbon sinks. And scientists didn't want society to think that we had an out if we depleted our carbon budget. But because we've delayed action, taking action for so long, and we've depleted our carbon budget, carbon sinks have become more and more central part of the solution. So they can include natural carbon sinks, so increasing things like planting trees. They can also include engineered sinks, so capturing carbon at a natural gas or coal-fired power plant, or doing direct air capture and either sequestering that carbon or making new products out of it. All right, and I also just want to call out the education and health component of Project Drawdown, which I think is really interesting and not one you necessarily always see in a solutions framework. Project Drawdown talks about the importance of things like family planning and universal education as an essential human right, and something that also has a cascading outcome of reducing population and reducing associated emissions. Another solutions framework that I want to call out is the Exponential Roadmap, which is a roadmap that was released in 2019, published by an international group of experts that map out 36 cost-effective solutions that we can take today to put a significant dent in emissions. You can see that decarbonizing the energy industry, which energy shows up not just in the top bar, but also within industry, buildings, and transportation, is a huge portion of the solutions that can drive those reductions. And remember, these are cost-effective solutions. So we really need to focus on scaling these already cost-effective solutions that are available to us, and also innovating in a few of the other hard-to-abate sectors like marine transport, industrial process heat is another challenging one, and also innovating on some of the engineered carbon sinks, the carbon capture technologies. All right, so I want to dig into this concept of cost effectiveness, because if solutions aren't cost effective, it's really challenging to scale them. This chart is from a seminal study from McKinsey that was initially released in 2010 and has been re-released a couple times since then. The x-axis shows the potential carbon reductions that can be achieved by different types of solutions and measures, and the y-axis shows the cost per ton of CO2 abated. So all of the solutions that are below the x-axis, you can make money on pursuing. Most of them are energy efficiency measures. Literally, as we'll talk about in the energy efficiency lecture, money being left on the table. And the huge potential there for cost savings and greenhouse gas reductions. For the other measures that are above the x-axis, this was released in 2017. Since then, many of those measures have become even more cost-effective because, like wind and solar and battery technologies, where innovation and manufacturing scale have helped drive down costs to the point where, as Diana probably talked about on Wednesday, wind and solar are the cheapest electricity resources that we can build on the grid today. All of these solutions would be even more cost-effective if you priced in the external cost, the negative impacts that society has to pay for the impacts of climate change, something that's called the social cost of carbon. I think Diana talked to you on Wednesday about the difference between the private cost that we pay for a good and the social cost, and how the difference is externalities. They can be negative or positive. And in the case of climate change, they're all very negative, right? And someone has to pay that external cost, right? But if you put a price on CO2, it helps ensure that the polluter is the one that pays that cost, and it doesn't fall disproportionately across society and consumers. There have been a lot of efforts to put a price on carbon and to internalize that external cost. One of the most effective ones is when governments just pass policies that mandate a price, like through a carbon tax or a cap and trade program. Many states and countries and regions have legally mandated prices on carbon. This map shows the different areas that do across the world. It includes, the EU. California has their emissions trading scheme. The The EU also has a cap and trade mechanism. The US, however, doesn't have a nationwide, federally mandated price on carbon. There have been attempts to in the past. When I moved to DC in 2009 to work on climate policy, that was actually when federal climate legislation failed, and they were attempting to launch a cap and trade mechanism as part of that federal legislation. But here we are 14 years later, in part because a price on carbon is so politically unpalatable in the US. President Biden was very successful in passing the Inflation Reduction Act, the IRA, that, as we'll talk about in a minute, makes huge progress in addressing climate emissions in the US, but it's not by putting a price on carbon, it's by throwing a lot of money at the problem. Even though carbon tax or cap and trade would have been much more efficient at addressing this issue, but politically it just wasn't an option. Okay, so you've got government mandated prices on carbon, but there's also voluntary carbon markets where several companies like Microsoft and Google and others have mandated a price on carbon within their companies and that influence their decision making. And we've seen this happen more and more recently as corporate social responsibility and sustainability has become more mainstream among our businesses. One of the big challenges, though, with putting a price on carbon is what level do you put it at? When you have a cap and trade mechanism, the market decides, but as we've seen in California and elsewhere, market design can be really important in making sure that the price, the market determined price is reflective of what it should be. In the EU, the price of carbon typically trades about $100 a ton of CO2. In the US, more recently, it's been around $30 a ton. So it gives you a sense of kind of the wide range of carbon pricing that we're seeing across these systems. And many would say, including researchers at Stanford, that neither of those are high enough to reflect the true social cost of carbon on society. But even a $30 cost of carbon would be pretty significant in driving some of these solutions. Okay, in the last few minutes, I want to shift to talking about the international climate negotiations, which is something that I worked on for several years, trying to garner the political will amongst almost 200 countries to agree on action to climate change. So because we talked about that CO2 is a well-mixed gas, and the carbon budget is limited, we need collective global action on climate change. Climate change is what's known as a prisoner's dilemma in economic game theory, where all parties acting unilaterally don't have an incentive to cooperate, to work together to solve the problem. To give an example, hypothetically, let's say China decided to unilaterally rein in their emissions. That still wouldn't necessarily solve the problem because all the other countries are still emitting, right? And CO2 is a well-mixed gas. So because of this, it's very challenging to garner that collective action on climate change. Even though if all countries came together and acted together, that's the ideal outcome, right? Because you're curbing climate change, no one country has a disproportionate burden, and you don't have really harmful impacts from climate change. So because of the need to garner that collective action, since about 1992, countries under the United Nations have been trying to come to an international agreement about how the world will act together. In 1992, that's when about 200 countries that are members of the United Nations agreed to the United Nations Framework Convention on Climate Change, also known as UNFCCC, where the countries, it was an agreement aimed at stabilizing greenhouse gases to safe levels. And one of the significant outcomes of the UNFCCC negotiations was that in 1997, the Kyoto Protocol was adopted by those same 200 countries. that included greenhouse gas reduction targets by developed countries only. The US actually didn't sign on to the Kyoto Protocol ultimately because they didn't like the fact that China wasn't included. And they were also afraid that it would be costly for the US. But the irony is that the US would have met their Kyoto Protocol targets because of coal to gas, fuel switching in the electricity sector, as well as transportation efficiencies that the US has achieved. So already not a very successful agreement since the US wasn't a part of it, and the US is a big emitter, but also Russia and Japan ended up missing their targets. So the success of the Kyoto Protocol has been fairly mixed. Since the Kyoto Protocol, though, the UNFCCC has really focused on developing an international agreement that includes GHG reduction targets for all countries, including the developing world. In 2015, parties to the UNFCCC did just that. They adopted the Paris Accord that includes targets for developed and developing countries. One of the challenges, though, with the UNFCCC process is that it's a consensus-based process. That means any one country can raise their hand and hold up progress to an agreement. And the result has been, a watering down of the agreements that we've seen. Because, if you think about where different countries are coming from, you've got different perspectives and priorities. The US, for their part, hasn't until this year, until I guess August of last year, had federal climate legislation. So they couldn't commit to anything in these negotiations. And also under President Trump withdrew the US from the Paris Accords, something that President Biden reversed in, I think, his first couple months as president. So there's a lot of politics involved with how the US shows up at those negotiations. China, for their part, for a long time, they didn't want to sign on to anything if the US didn't, right? They didn't think that was fair. But more recently, they've kind of, just in the past few years, have done a little bit of a 180 and became much more progressive and a leader on committing to action in the climate negotiations, in part because air pollution has been really detrimental within that country, and they've wanted to pursue clean energy solutions that address those air pollution challenges. You've got oil-producing states like Saudi Arabia who delay action because they have a very big vested interest in the world continuing to consume oil. And then, of course, you've got the vulnerable countries like the Maldives who are not big contributors to climate change but need help in adapting. In 2009, when I worked on the negotiations, this is a picture of the president of the Maldives convening his cabinet underwater to really drive home the point of the importance of action. So lots of challenges contributing to reduction in ambition around climate action at the international level. And the results that we've seen is a breakdown of negotiations like you see here in COP16 in Cancun in 2010 and in Durban at COP17. And so that's why we end up with this ambition gap. But I want to leave you on a positive note. Regardless of what's going on at the international level on negotiations, there's a lot of progress happening on the ground today. And it's a really exciting time to be a part of this moment in the US and elsewhere, where there's a lot of momentum in the private sector for federal and state policies to act. I talked about the fact that wind and solar are the cheapest electricity resources, and because of it, we've seen huge growth in those energy resources on the electricity grid in the US and globally. And that growth has just blown through expectations. You've got IEA expectations for solar here on the left, and then actual growth that you see has been exponential. Same with electric vehicles. You've got IEA, Bloomberg, even OPEC saying that by 2040, half of the transportation market is going to be electric. So pretty significant. I also talked about the Inflation Reduction Act not necessarily a climate policy by name, but has the potential to reduce greenhouse gas emissions in the US by 40% by 2035, which is making huge strides towards the US climate goals. And really just an unprecedented level of funds becoming available. So it's really an all hands on deck, call to action. Now is the time to start getting out there and helping to deploy solutions to climate change because we have the money to do it, we have the resources. All right, and just want to end by saying, encourage you all to think beyond your own carbon footprint and think creatively about the ways that you can have meaningful impact on climate change, from how you vote to what you do in your careers, to how you engage with the community around you. Thank you.